Hello, I want to talk about API gateway, a commonly used concept in system design interviews and the typical component of a web application. So let's see, let's go over what it is, its typical functionality, and then for each typical functionality piece, talk about in more detail. So what it is, a system is located close to an edge of a web application, usually after the load balancer. It's processing incoming requests at L7 network layer. So the architecture in a simplified form would be to have some form of web client, like a browser or a mobile app. It resolves some DNS of your service or your application, then goes to load balancer, and then load balancer forwards it to API gateways. API gateway would typically be like a stateless service, which then does a bunch of preparations and work and forwards things to your backend. And backend here I just put one component, but in reality it's going to be of course as complex as it needs to be. So this allows a more simple and efficient architecture for backend services, taking care of a number of things that are important for random requests from the internet, but which are not necessarily applicable for internal traffic. And I would go over them in a bit. So what's a typical functionality? Some of the things, but not limited to, is TLS termination, request response transformation, rate limiting, caching, authentication authorization, and login. Let's go over each of them. For TLS termination, a modern standard is to have interactions between client and service to be done with encryption, and SSL TLS is pretty much a standard. So data is being encrypted in transit, so it's harder to eavesdrop, especially if it's some sensitive data is being transferred. And then there is a whole protocol of how handshake is established between client and server. And then, for example, encryption may not be as necessary for internal networks. Also, it varies. There are some regulations. For example, for federal environment, it's important that between nodes, traffic is still encrypted. And also, if you want extra protection, for example, if you host it on the cloud and have concern that cloud provider may get compromised or something, you may also want to add additional layers of encryption. But then processing requests on the 7 layer also requires decryption, just to know what's inside, and response need to be encrypted back before return to the request sender. So request response transformation is data may need to be processed before being sent to the backend or back to web client as a response. For example, backend services may just use gRPC or just have a different interface. So API gateway can apply this adapter pattern and not require web clients to think or allow internal implementation details of services, and they can just send in data in a format which is more convenient and makes sense to them and from perspective of the internet, whereas API gateway transforms them to what's more needed towards backend services. Let's talk about rate limiting. So there are bad actors or some bugs in web browser which can cause DDoS. Don't underestimate bugs, by the way. Sometimes your own application may DDoS you when you say didn't put a stop on some reloads. That's why it's always a good idea to have some common framework which limits a maximum number of reloads of some information. And to protect against those, rate limiting is a common technique. It's pretty effective. Puts limit on total number of requests to endpoint in a given time range, 1 minute or 1 hour sometimes, or sometimes even 1 second. Or it can put a maximum number of requests from some caller, some maybe client based on some authorization or authentication header, or maybe IP address, similar. It can be used in conjunction with authentication to better deal with random data spam. But if you have more a local in-memory rate limiting, then it becomes less relevant because it's then just cheaper to evaluate rate limit itself than do any form of authentication validation. And also you need to make sure that authentication cannot be easily DDoSed itself. But if it's something distributed with centralized storage like Redis, then some authentication check would be pretty beneficial, especially if your authentication can be done with some checksum validation without calling a backend service. Let's talk about caching. It's a technique to reduce the load on the backend by saving responses to common requests in memory or in distributed systems like Redis. so they can be fetched from there instead of being recomputed like every time by the backend. On API gateway level, this various kinds of configs, for example, can be good to cache. And often even caching for several seconds can have a huge load reduction for the backend. Because like if you have like, I don't know, 1000 or like 10,000 QPS for the same, just like, hey, fetch me some config or like common information, then you can reduce load by like multiple orders of magnitude by caching. And like several seconds is usually a delay where like, yeah, even if things change, it's like, it's okay to like have it a little bit stale. Caches can be like manual, like LRU, TTL, and there are more. Combinations of LRU plus TTL is quite powerful for a variety of use cases. LRU is typically used if you like need to cache a lot of different things, but have limited capacity. And TTL is a standard technique just to like expire things when they like they pass certain like threshold. Let's talk about authentication and authorization. These are used to check that user is who they claim they are and what they're allowed to do in the system. There's typically some form of auth token passed in request headers that can be validated by the system, either by calling backend service or in place with some like temporary HWT tokens, for instance, that can be issued and be valid for like 1 day, for example, or like 7 days, or maybe even 1 hour or something. Like it can be configured. But basic idea is that you may have some system which allows validation without calling any backend services, which can be pretty powerful and like make it more resilient to failures. Authorization offers a more granular permission check, like what the user can do. Can they call specific endpoint or a service, or can they access certain data? It's typically based on some RBAC system once the user identity has been established and it's part of the backend system, or like maybe it can be configured in API gateway itself. So depending on like what kind of granularity you need, you can also have some like more like common identity establishment and pass this identity along with the requests to the backend services, and then like backend services each can have their own like RBAC. Yeah, so overall pretty important component of the system. And then let's talk about login. So a lot of debugging power comes from having logs. Like once you don't know what's going on, like there's some bugs or issues, it's good to have like some information about what actually happened and what was done, what maybe failed. If costs were not prohibitive, it would be great to log like pretty much everything that happens on the service, including like API gateway service. But costs should be considered, and we cannot log information on like every request probably, unless the traffic is like pretty low. We can have like access logs for like who gets to like our system, authentication, success or failure, some rate limited information, maybe some request response metadata that hey, we have this request, it returns status code like 200, and like here's the size of the response. But even those can be like pretty huge, so most likely they're going to be limited and like sampled. And due to potentially huge number of requests, login has to be configured in a pretty smart way. Probably want to prioritize errors, warnings, and only most important info logs. And then debug logs can be used temporarily. Maybe like if you have some weird bug, you can like redeploy a service with debug logs enabled. Or maybe even like just change a config if it's like can pick up it in real time. So yeah, that's gonna be it for API gateway. Usually during the system design interview, you just use it as one of components. You just have to mention what functionality it has, and only if the interviewer asks you for more details, you can go into that. Or like if you kind of have some time to do like a deep dive, you can choose API gateway and go into it. And it's a very good pattern. It's a thing that's like used for almost like every web application. And you kind of want to remember that like initial diagram several slides back. Let me get back to it. Yeah, so this is like a common thing for a whole like web application, and you kind of wanna put those components in like as a more or less a standard when it comes to designing one. Cool. Thanks for watching.